So in this video, we're going to have a little look at the unit circle, and we're also going to talk about radians for the first time in this course. So radians might be a bit new to you. Just hold on for a second. We'll go through the unit circle, and then I'll explain a bit more about what this is down here. So a unit circle is just a circle. The defining factor is that it has a radius of 1 unit. So it's just 1. So any circle where the distance from the middle to the outside is 1 is a unit circle. And the reason that we have this unit circle is so we can define a lot of the trigonometric properties that we use, and also so we can explain a lot of concepts. So it's just a circle with a unit, with a 1 for a radius. So I've got here 2 unit circles. The one on the left here might make a bit more sense to you. It's in degrees. So it starts at 0, it goes 30 degrees, 45, 60, 90 is a right angle, 120, 135, 180 is straight, and it works its way around. So we've seen that quite often. You see 90 degrees all the time in trigonometry. You've probably seen 360 or 180. I don't know if you skateboard or wakeboard or anything like that. You probably have seen those ones as well. So we see that quite a bit, and I think most people would be quite comfortable with that. The one on the right here is still a unit circle, but that one's expressed in radians. So they're 2 different ways of expressing how far around the circle we're going. So I'll explain a little bit more about the unit circle, and then we'll have an in-depth look at what radians are. Okay, so there's just a close-in of the degrees. So if you want to have a look at that, we won't see that too much. What we'll be doing in the course will be mainly radians, but keep in mind that that is what a unit circle for degrees looks like. What you will see quite often is this cast diagram here. If we just have a look at the formula sheet, we're on to page 3 now, and the cast diagram is this one here. So that tells you quite a bit of information, though it looks quite simple. What it's saying is where each of the ratios is positive. So this one up here is the first quadrant, and in the first quadrant, A stands for all. So if you have sine, it's positive, tan, positive, cast, positive. Okay, so if we have sine of 30 degrees, and we mark in 30 degrees, okay, the answer will be positive. Right? If we mark in, say, 70 degrees, and we find the tan of 70 degrees, that will also be positive. So it doesn't matter what trigonometric ratio we use. If it's less than 90 degrees, they will all be positive answers. Okay? In the second quadrant over here, only sine is positive. So if you keep in mind, back to that degrees diagram, we're looking at between 90 degrees and 180 degrees here. So anything between 90 and 180 degrees, only sine is positive. So if we had sine of 100, our answer is going to be positive. If we had cos of 100, our answer is going to be negative because only sine is positive in that second quadrant. Okay, if we look at the third quadrant here, from 180 to 270, only tan is positive. So tan of 200 will give us a positive answer, but sine of 200 will be negative. Okay, so between 180 and 270 degrees, only tan is positive. You can probably guess with this last one, from 270 to 360. Oh, it is the fourth, sorry, breaking things. It is the fourth quadrant. Okay, and only cos is positive in this one. So cos of 320 would be positive, but tan of 320 would be negative. Okay, so that cast diagram on your formula sheet tells you whether your answer is going to be positive or negative, depending on where it fits into those quadrants and also what trigonometric ratio we are using. So that's quite handy to know. Where we're going with this is you will be given, say, like a sine of 100, and you will need to find the answer. So where we previously would have put it into a calculator and got, say, a decimal answer, you are now going to have to calculate it. And part of that includes deciding whether it is a positive or negative value. Okay, so this is right at the start. We're just deciding whether it's positive or negative. And what I find a lot of students find really good to do is when they answer a question, they actually draw that cast diagram and they put their line where they're talking about. So if they know that they've got one of 110, say sine of 110, they pop a line on their cast diagram to remind them that, well, sine is positive, we're in the second quadrant, and that helps. And we'll be drawing a lot of diagrams later on as well. So you will see quite a bit of that. So this is another unit circle. I filled in with all the degrees there. I've also started to look at radians, okay, and that's what we'll be doing. I've got one more thing to show you, but we're looking at getting it into radians. So you can see here, this again is from your formula sheet. And you can see there that it gives you radians. So if you have sine of pi, which is a radian, your answer is 0. If you have sine of pi on 4, your answer is root 2 on 2. If you have sine of pi on 2, your answer is 1. Okay, so if you can get your degrees into radians, you can find what sine, cosine, and tangent are very quickly, and then you just have to look at your cast diagram to decide whether it's going to be positive 1 or negative 1. Okay, so that's where we're going. So you're probably wondering, what on earth is a radian? It confuses a lot of people because we don't really see it before now. You don't really see it at school, but it's just a different way of measuring angles. So what we're used to is degrees, where you kind of stand in the middle of a circle and you look, and we're measuring from that center. Okay, we're looking at degrees. What radians do, what radians do is they actually look at the distance that has been travelled around the outside of the circle. Okay, so degrees are looking from the inside out, essentially, and radians are a distance around. They are just different ways of doing it, really. If you look at degrees, degrees are based on 360 degrees, and they're broken up into lots that way. And we've seen that quite a bit. We see that with our 12-month calendars, or our 60 seconds in a minute, or 60 minutes in an hour. That kind of thing comes from the same era as degrees. Radians is just a different way, same as we have degrees in Fahrenheit. Okay, they're just two different ways of doing it. Radians can be very easy to manipulate once you get the hang of them. You've also probably seen radians somewhere else, because if we look at our unit circle again, and we want to find the circumference, we can find the circumference using 2 times pi times the radius. Okay, that's actually in radians. Okay, we normally put it in a calculator and find it in degrees, but that formula is in radians. And if we use our 1 here as our radius, the circumference of a circle is 2 times pi times 1, which is just 2 pi. Okay, so the distance around the outside in radians is 2 pi, and we can see that back on our slide up here, all the way around the circle, it's 360 degrees, or it's 2 pi. So we have seen it a little bit, but you probably didn't know where it came from. So what we want to be able to do by the end of this course is convert between degrees and radians. Okay, so if they give you a problem in degrees, you want to be able to convert it into radians and vice versa. The easiest way of remembering it is 2 pi is a whole circle, so 360 degrees, and half a circle is 180 or pi. So if you think that pi is 180 degrees and remember it that way, then half of pi is half of 180, which is 90. So on your formula sheet here, these ones up the top are ones you should be very familiar with and should be able to do quite easily by the end of it. We can see there, actually I might do it on the slide so I can write on it. So we know that 2 pi is 360 degrees. Okay, half of that, half of 360, half a circle, 180 degrees is pi. Half of that is 90 degrees. Okay, 0 is obviously 0, we can leave that there. Pi over 3. What is pi over 3? Well, what's 180 divided by 3? So we're looking at 60 degrees there. Pi over 4. What's 180 divided by 4? 45. Pi over 6. What's 180 divided by 6? 30 degrees. Okay, the other way we can do it, and the way I'll show you how to do that last one, is by using our formula sheet on the bottom of the second page here. It tells us how to convert radians to degrees and degrees to radians. So if we want to convert radians to degrees, we multiply by 180 over pi. And if we want to go from degrees to radians, we multiply by pi over 180. So I'll show you that slowed down a little bit. So we've got radians. We've got radians. We want to go to degrees. We're going to multiply it by 180 over pi. Okay, and you can do this for every single one if you want to. You are not expected to know it all off by heart. Okay, so we've got 3 pi times 180 over 2 pi. Okay, I could go 180 times 3 and work that out, or I can just half 180, which I know is 90. So 3 times, oh, missed a bit. 3 times 90 pi over pi. Well, again, got 2 pi's, so they can cancel out. So we're left with 3 times 90. So if we think about that circle, we start at 0, we go 90, 180, 270. Okay, so that's one way to work it out. Okay, the other way is they actually give you a little hint on your formula sheet here on this cast diagram. They actually show you here that pi on 2 is 90 degrees, 90, 180, 270. So they give you some of them there, if you can just remember to look at your formula sheet and check for that. Okay, so we can go from degrees to radians. We can also go the other way from radians to degrees just by using that formula sheet. Okay, we've kind of gone through that already. So 360 is 2 pi, 180 is pi, 90 is half of pi. Okay, 60 degrees is pi on 3, pi on 4, pi on 6. And you'll be surprised at how quickly that becomes really familiar to you. But if it's not, we're using that formula sheet. Okay, so when you do your exercises, you'll start by using this until you're completely comfortable, and you'll find it will drop away quite naturally by itself. Okay, as I said, I think in the previous video, we're going to be swapping between degrees and radian mode on our calculator quite frequently, so you need to be aware of what mode your calculator is, and you can see that at the ribbon down the bottom. So we've used this standard decimal button quite a bit, and and you can see next to it the degrees, radians buttons. Okay, so you can give your answer as standard, which is what we like, unless it asks you for decimals, which we can use as well. Okay. Have a play around with your calculator. There is a trig tab, which is all of your trig stuff in there. You can see our sine, cosine, and tangent up the top there. Yours will look a little bit different if you've got the new calculator. The opposite of sine, cosine, and tangent are right below it, which makes it easier to remember as well. Okay, so at the end of this unit, what you should be really, really comfortable doing is converting between degrees and radians. And you should also be able to pop those values, so these values here, onto a unit circle without too much hassle, and you should be able to tell me which ones are positive and negative. Good luck.